This week we'll be analyzing patterns and relationships. So here are the standard goals broken out into steps. First, we'll generate two numerical patterns using two given rules. Next, we'll identify apparent relationships between the corresponding terms. Then we'll form ordered pairs consisting of the corresponding terms from the two patterns. And then finally, next week, we'll move into graphing the ordered pairs on a coordinate plane. That's not the focus of this week. So let's practice first by looking at rules that can be applied and completing tables. So Thomas and James are new employees at the Choo Choo Trains Company. Thomas assembles 2 trains each day and James assembles 4 trains each day. In the table below, you will see the number of toy trains each employee assembled during various weeks at work. In part A, it says, following the rules described above, fill in the missing values in the table. So first, let's take a look at Thomas. Thomas makes 2 trains each day, while James makes 4 trains each day. So we're going to color code for these different rules. And here Thomas is red, and James is blue. And now we're ready to fill in our missing values. So let's focus first on rule 1 that says 2 trains each day. So Thomas, we're going to count by 2s as we go from one day to the next. So first we want to make sure that the days go in order without skipping any, which they do. We have day 1 through 7 here. So if we count by 2s, we have 2, 4. The missing value here would of course then be 6, 8, 10, 12, and 14. So now Thomas's values are all complete, going up by 2s, following the rules that he assembles 2 trains each day. This means that by the 7th day, he has made 14 trains total. Now let's use James's rule. So James makes 4 trains each day. So on day 1, he makes 4. Then on day 2, he makes 8, 12. This value is going to be 16 because I add 4 to the previous value. Then 20, then 24. And finally, by day 7, he's made 28 trains. So in question B, it says, what do you notice about Thomas's and James's toy train totals? Describe 2 different relationships you see in the space below. So let's talk about that. What do you notice as the relationship between the first column of numbers and the second column of numbers? One of the things I notice is that James is able to make twice as many trains as Thomas. So on each day, he made twice as many. So 2 times 2 is 4, 4 times 2 is 8, 6 times 2 is 12, and that pattern holds true throughout. So each day, James makes double the number of trains as Thomas. I also notice that for each day, if we multiply the number day by the number of trains each gentleman made, then we get our answer that goes into the chart. So on day 1, when we multiply by 2, we get Thomas's trains, and when we multiply by 4, we get James's trains. And that holds true throughout as well. So on day 7, when we multiply by 2, Thomas made 14 trains, and when we multiply by 4, James made 28 trains. So there's just a few relationships that we can recognize with Thomas and James and their trains. For our next problem, we have a multiple choice question in which we're told to circle the correct letter below with the correct rule for the input-output table. So here are the inputs and here are the outputs, and we need to evaluate each of these options and see which one matches the table. So in part A, it says multiply input by 6 and then add 3. So let's test that theory. If the input is 2 and we multiply it by 6, we get 12. And then the second part of the rule is to add 3, which would give us 15. So already we know that it can't be A because the output was 18, which is not the same as 15. So we can move on to B. The second rule offered says add 16 to the input. So let's test that theory. If I have 2 and I add 16, I get 18. So far that rule holds true. Let's try it for the second input. So our second input is 3. So again, I'm going to apply the rule and put 3 plus 16 equals 19. But the second output in the chart is 23. So those don't match. So B is not the correct rule either. So now let's try rule C, which says multiply the input by 6, then add 6. So I'll start with 2, and I'm going to multiply it by 6, and then I get 12, and then I add 6, and I get 18. Let's try it with 3. 3 times 6 is 18, plus 6 is 24. So that cannot be the correct rule either. So we're going to cross those out. So it's going to have to be D, hopefully. Let's make sure we get this correct. So the rule for D says to multiply the input by 5. So we get 10, and then add 8, and we get 18. When we do it with 3, we get 15 plus 8 equals 23. 4 times 5 equals 20, plus 8 equals 28. And then 5 times 5 equals 25, plus 8 equals 33. So we have in fact found the correct rule, which is letter D, to multiply the input by 5, then add 8. For our next problem, it says Anna has $5 in her piggy bank. She makes $10 an hour for every hour she works and puts it straight into her piggy bank. So along the top, we see the number of hours she has worked, and then the total dollars is in the second row. So Anna makes the same amount every hour. After the 6th hour, how many dollars will she have in her piggy bank? So because she started with $5 in her bank before working any hours this week, it means that even when she had no hours worked, she already had $5 in her piggy bank. After she worked 2 hours, making $10 an hour, that's $20, plus the 5 that she already had in her piggy bank gives her 25. So the rule here would be that we multiply the input times 10 and then add 5. So our rule, multiply input by 10, then add 5. So we see that's true for 4 hours worked. 4 times 10 is 40, plus 5 is 45. So now we need to find the value for 6. So when she's worked 6 hours, we multiply that by 10, and she has $60, plus 5 gives her 65. So the correct answer is D, $65. Okay, so now we're ready to try to come up with our own rules without multiple choice responses. So we're going to look at the first input to output of 3 to 15. And I'm going to think of different ways that I could get from one number to the next. So probably the most obvious one would be to multiply by 5 and get 15. So let's try that rule. I try it with 5, and already that rule is not going to work because I get 25, which is not the same as 19. So the rule cannot be multiply by 5. Instead, let's try adding 12. 3 plus 12 equals 15. 5 plus 12 equals 17. So it also cannot be to add 12. So since it doesn't seem to be one of our more basic ones, we need to think about it being possibly two rules that are being applied. So now I'm going to look for other relationships. So if I take 3 and I times it by 2, then I get 6. And then I need to think, how would I get from 6 to 15? Well, I could add 9 and get there that way. So now let's try that with 5. I'm going to times it by 2 and get 10. And then if I add 9, I get 19. 7 times 2, 14, plus 9, 23. I think I might have found it. If I take 9 and multiply it by 2, I get 18, add 9, get 27. So we have found our rule that we first multiply by 2, then add 9. Okay, so we're going to do one more in this video segment, looking at this input-output table and trying to determine what the rule could be. So as I look at the numbers in the input and how they relate to the output, I'm noticing something. I noticed that 3 times 9 would be 27. So this is close to that 9's fact, but not quite. Same thing here. If I multiply 5 times 9, I should get 45, but this output is 44. If I multiply 7 times 9, I should get 63, but this is 62. And if I multiply 9 times 9, I should get 81, but this is 80. So this is really close to having a rule of multiplying by 9. However, each one of them is one short of that. So I actually have the rule to multiply by 9 and then subtract 1. That applies in each of these as we just went through that. So 3 times 9 equals 27, subtract 1, we get 26. And that's going to work all the way down where we multiply by 9 first, and then we subtract 1 and we get our output. There will be a few other videos listed in the learning section this week if you need to visit other ones. Please don't forget to reach out and ask for help if you need it. Good luck.